Alright, so I have an example here on red that I want you to attempt. Okay, so this is the question. It's saying a uniform wooden beam 3 meters long is a mass of 120 kilograms. So on part A we want to calculate the mass of the beam per meter, and on part B it's saying hence calculate the mass of a 120 centimeter length of the beam. I'm going to be giving you 3 minutes to work this one out, so you may pause the video starting from now. So this is the solution. We're starting with part A, in which we want to calculate the mass of the beam per meter. This is a red. We want to calculate the red mass per unit length, mass of the beam per meter. So on part A we're saying for the mass of the beam per meter, then remember we said we divide. For us to calculate red, to get red, we divide. In this case we're dividing mass, which is 120 kilograms, and we're dividing that by the length. In this case is 3 meters long, so that's what we are dividing to get the red in kilograms per meter, right? So what we're gonna get here is 40 kilograms per meter. That is the answer to part A. Okay, so we are through with part A. I hope you got that one correct. What I just want you to note is when we get a red, like in our case we've got 40 kilograms per meter, in other words it's 40 kilograms for every 1 meter. So that's important for you to always note, in order for you to understand how we work out some of these problems. Like if we go on to part B, which requires us to calculate the mass of a 120 centimeter length of the beam, we are saying that if 1 meter, right, if 1 meter has a mass of 40 kilograms, then what about 120 centimeters, which is now in this case 1.2 meters? So what we do here is we multiply 40 by 1.2, and the solution will come out in kilograms. Where has the 1.2 come from? 1.2, we know that 1 meter has 100 centimeters, so we calculated, or we converted 120 centimeters to meters. It comes out as 1.2. so we are multiplying the red, that is 40 kilograms for every 1 meter, and we are multiplying that by 1.2, the length of the beam, in order for us to get the mass of a 120 centimeter length of the beam. So in our case what we get is 48, and that's 48 kilograms, and that's the solution to part B. I also hope you got that one correct.